We've been talking about Gibbs free energy, and now we're going to explain what it is. The calculations we performed in the previous section would be a lot easier if we did not have to separately calculate the entropy changes in the surroundings and the system. A new thermodynamic function was defined by Willard Gibbs, who lived from 1838 to 1903. Gibbs free energy is given the symbol G for Gibbs. He defined his free energy change as delta G system equals minus T delta S universe. It seems a little funny, but on the next slide we'll show where that came from. It states that a decrease in Gibbs free energy of a system, their system, is characteristic of a spontaneous or product favored reaction at constant pressure and temperature, right? Because if delta S universe is positive, then you have this spontaneous reaction. That means delta GS, the Gibbs free energy, has to decrease, has to be negative. Before we go on with the equations here, Google Josiah Willard Gibbs. He made incredible contributions to thermodynamics, mathematical physics, a whole host of topics. He was the first American to receive a PhD in engineering here in America. And he's probably the least known, most impressive physicist of all time. So it'd be interesting to read about him. Okay, let's go to our equation. We start with equation number 1, where we have the change in entropy of the universe is a change in entropy of the system plus the surroundings. And then what we're going to do is put in this definition here. Delta S surrounding is negative enthalpy change per the system divided by T. Okay, so that's just a direct substitution. Now multiply through by T, and you get this right here. Okay, but we've already stated that the Gibbs free energy is minus T delta S universe, so that goes right over there. And then we just rearrange the right hand side. We move delta H system there and minus T delta S there, because we always like to start with positive numbers. And let's erase this so you can see the beauty here. And what this is telling us, equation 4, that's what we wanted to get to. Notice how it's all systems, okay? So delta G naught system, Gibbs free energy, is negative for product favored reactions. Because for product favored reactions, delta S universe is greater than 0. So since the Gibbs free energy is defined as the negative of that, that has to be negative for a product favored reaction, and then vice versa. Gibbs free energy will be positive for reactant favored reactions for the same reason.